Hi everyone. Again, we are back with the duplicate subtree problem. So, after a long day of linked list problems, we are again blessed to have a tree problem. So, let's understand what it is. So, एक बाइनरी ट्री दिया हुआ है उसमें we need to find the subtrees that are duplicate. By subtrees we mean कि like for example इसमें देखते हैं 1 2 4 3 2 4 4. If you see nicely, you would see 2 4 and 2 4 are same. So that is a duplicate subtree, right? So you have to return 2 4. And again, if we see nicely, this 4 and this 4 are same. So we have to return that. So let's just make you understand. Like if at any point we get a duplicate, that means suppose we have this is a subtree and this is a subtree. Then this should be exactly same. These two should be exactly same, both by value and both by structure. This should have the same structure and this also should have the same structure. Means the left side should be same to the left side of this subtree. The right side should be same to the right side of this subtree and so on. So do you have any idea like how can we proceed? Like if we think nicely, the first thing that should come to our mind is like if we know this is going to repeat somewhere, then obviously we have to store it somewhere, right? Like if this is same as this, how can we compare these two? If we already know that there is such a subtree, so what can we do? Can we store the subtree like this? Can we store all its node and iterate over the whole database and check if we get a subtree, or we can do something else? Yeah, so here comes the concept of serialization. Like we will convert the subtree to a string and check if that string is present already in our database. By database here I mean any map or some uh, index based storage. So in C++ I'll be using map. So let's understand how. For example, 1, 2, 3, 4, 2, 3, 4. So by observation only we can say this subtree is same as this subtree. But the question here is how we will know that this subtree is already present in this subtree. Yeah, so we have to write some kind of representation or coding. For example, we can store it like this in the form of a string. Suppose if we use a map of string and int, and we write the key value as like, for example, if we have this 2 in its left, right 3 and its right 4. Okay, so this is the representation of this subtree in the string form. Now, when we would see the representation of this subtree, this would also come same 2 in left it has 3 or in right it has 4. So this is another same string. Now this is already present in our database. I mean the map. We can get it in O of 1, so doesn't require to check every uh, subtree. So since this string is already present, so we can push back the node of this subtree, that is 2. I mean the node pointer. So this is how we'll proceed. So I hope it's almost clear. With the coding part we will be like more clear. So let's try string serialize. We have a root, then we have our answer of what node pointers, and also we have a map which store all our subtree in the form of a string. So that was string int and map. Yeah, I am passing by reference, otherwise it will make a duplicate copy and all our optimization everything will be hell. So I will return the string. Okay, so for example, in every subtree I will return the subtree in the form of a string. So if root is null, then what to do? Return empty string, because there is no subtree left for a null root. Now string current subtree should be, how can we represent to string the root value, I mean the root data this can have. Okay, then suppose I am right spacing the left child and right child with the bracket, or any character of your choice except numbers, otherwise numbers would overlap. For example, comma, okay, let it be bracket, plus uh, serialize the left subtree, the left subtree answer map, and again separate with some bracket so that to distinguish between the left and the right. We can use LR, but this would also work. So serialize the right subtree. The right subtree is root of right, and answer and map. So again, now we will get our subtree here because of recursion, right? So now if there are three duplicate subtree as well, we have to return it only once, right? What I am trying to say is this is our subtree. Yeah, so suppose this is a subtree. So suppose the value is 1, here also the value is 1, and here also the value is 1. So we don't want to repeat it again and again. We'll repeat it only once. So we'll push our answer if map of current subtree is 1, means we got it once, then we'll push it to our, push this root of that subtree to our answer, and map of current subtree, current subtree should be incremented. So that's, I think, the code part, I mean the serialize function. I will again show you once. Let me check if it's working or not. I don't want to mess it. So create a vector of node star answer, create a map of string and int, and simply call serialize root uh, answer map, and return our answer. I think this should work. Still, I will have to check if I made some mistake. Okay, answer dot push. It should be push back. I think there is a typo. Ting, 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 ting. Yeah, again there is a typo somewhere here. Car, I forgot the car spelling only. Yeah, I think it's working fine. Let me run it for all the test cases. Yeah, it's working fine. Okay, we got our coin as well. So now let me just explain what is happening in every line. Yeah, so I am returning a string function. I am returning a string in the serialize function. So if there is no root, I mean if that is null, then we'll return an empty string. Then current substring would be, this is basically I am representing the subtree with the help of a string representation, like to the left what it is, to the right what it is. I'm representing it like that. For example, we can also, I think we can write it L R and try. So this should also work according to me. Yeah, yeah. So this is working. So what I'm trying to say is I'm representing my subtree in a string form. Like in the left this is present, in the right this is present, in the left again this is present, in the right again this is present. and I'm storing it in a map of string. So if at any case I get the again the same map, same key that is already present in a map, then I would push it to my root. And since I have to push the duplicates only once, so if we find it for the first time, then we are pushing it. Otherwise, we are not pushing it. We are simply incrementing it. So that's the basic question. I think it's clear. And since we are like kind of DFS, we are traversing the entire subtree only once. So time complexity of n, and we are using a map. So of n as well, and we are converting the elements into the string. So we are not checking all the subtree individually. So it reduces our time complexity. So that's it, I think. Yeah, you can suggest something, or you can ask doubts in the comment section. So bye bye.